Welcome to Analytics Mastery Academy. My name is Kunal and welcome to video 1 of this series. Today we are covering section 1 of the exam, the Databricks Intelligence Platform. This section is only 6% of the exam, so you can expect roughly 3 to 4 questions, but it's foundational. If you don't understand the platform's architecture and compute model, the rest of the exam won't make any sense. Let's build that foundation. Databricks describes itself as a data intelligence platform. But what does that actually mean, right? At its core, Databricks is a unified analytics platform that combines data engineering, data science, machine learning, and BI on a single system. It's built on Apache Spark as the compute engine. But it adds a huge amount of value on top of that, like managed infrastructure, optimized runtimes, governance, orchestration, and collaboration tools. The key architectural concept is the Lakehouse. Traditional data architecture forced a choice. You either had a data lake, which was cheap, flexible, and stores everything, but it's hard to query and govern. Or the other choice was a data warehouse, which was fast, reliable, governed, but very expensive and rigid. The Lakehouse merges both. You get the flexibility of a lake with the reliability and query performance of a warehouse. Databricks runs on AWS, Azure, and GCP. The interface is the same regardless of cloud. Your code, notebook, and configurations are all portable. What changes is the underlying storage and the cloud compute provisioned underneath. The platform has 4 core innovations that the exam focuses on. First, Delta Lake. Second, Unity Catalog, Lakeflow, and Mosaic AI. For the exam, Delta Lake and Unity Catalog are the ones which are most tested. Delta Lake is a storage format that turns a regular data lake into a lakehouse. Let me walk you through its key features. Let's start with ACID transactions. Delta Lake guarantees that every write is atomic, which means it either fully succeeds or fully fails. No partial writes, no corruption from concurrent operations, and every read sees a consistent snapshot of the data even while writes are happening. Time travel. This is one of the most useful and most tested features of Delta Lake. Every write to a Delta table creates a new version. You can query any prior version using select star from my table version as of a version like version 5, or you can do a select star from my table timestamp as of a particular timestamp. This is incredibly powerful for rollbacks after bad data ingests. If a pipeline wrote corrupted data, you don't need a backup, you just query or restore the previous version. Schema reinforcement. Delta Lake validates incoming data against the table's schema. If a new batch has a column with wrong type or a required column is missing, Delta rejects the write. This prevents garbage data from silently corrupting your tables. Now, schema evolution. When you intentionally want to add new columns, you can use merge schema option or enable it on autoloader. New columns are added to the table definition automatically. Old data will have just nulls in the new column. Now talking about scalable metadata, Delta solves the small files problem that actually plugs the plain Parquelix. The optimize command compacts small files into larger ones, and the file level statistics enable data skipping. Spark reads only the files that might contain rows matching your filter. Talking about unified batch and streaming, the same Delta table can be a streaming source or a batch table. No copies, no syncing. One physical table serves both the use cases. If Delta Lake is the storage brain, Unity Catalog is the governance brain. Unity Catalog provides a single metastore that governs all workspaces in a Databricks account. Before Unity Catalog, each workspace had its own Hive metastore, which meant governance and access control was fragmented across workspaces. Unity Catalog centralize everything. The key concept for the exam is the three-level namespace, which is catalog.schema.table. For example, prod.cells.orders. This replaces the old two-level Hive namespace, which was schema.table. Remember this thoroughly. The exam will definitely have a reference for this. Unity Catalog provides fine-grained access control. You can grant or revoke privileges at any level. That means the entire catalog, a specific schema, an individual table, specific columns, or even specific rows. We will do a deep dive into this in video 7. Automatic data lineage. Unity Catalog automatically tracks column level lineage. If table C's revenue column is derived from table A's price column and table B's quantity column, Unity Catalog shows that chain without you doing anything extra. This is invaluable for compliance and debugging. Now talking about centralized auditing. Every read and write is logged into system tables. Who queried what, when, and what they saw is all ready for the regulatory review. Unity Catalog also manages external locations. That means the connections between Databricks and your cloud storage, and also supports federation for querying external databases without actually moving the data. Now talking about compute options, this is the most exam tested topic in section 1. Let me walk through each compute option and when to use it. Let's start with all-purpose clusters. All-purpose clusters are your interactive notebook-based clusters. You start them manually, multiple users can share them, and they run until you actually stop them. They are the most flexible, but also the most expensive per hour because they are always on while you are working. Use these for development, exploration, and any interactive kind of work. Job clusters. These are your production workhorses. They spin up automatically when a job starts and terminate when the job ends. You only pay for the compute time actually that you have used. For scheduled ETL pipelines, job clusters are the most and always used right choice. They are cost efficient and isolated, so which means no resource contentions with other users. Talking about SQL warehouses, they are purpose built for SQL queries and BI workloads. They have different runtime optimized for query performance, and they integrate natively with Databricks SQL dashboards and tools like Tableau, Power BI, and Looker. There is also serverless SQL Warehouse option, which is instant start, no cluster management, but slightly higher per query cost. For business analysts, running SQL queries, SQL warehouses are the right choice. Serverless compute for the notebooks is a newer option. Databricks manages all the infrastructure, cluster starts instantly, and you pay per second for the compute. Higher per DBU cost, but zero startup latency. It is good for bursty or unpredictable workloads. Now, talking about single node clusters, they have only one driver and no workers. They are for lightweight development, testing, or when you have data sets which are small that actually fit into your memory. They are not actually good for production scale kind of a work. High concurrency board, they are optimized for multiple simultaneous users. It enforces table level access controls, isolates user sessions, and manages resources fairly across users. Think of it as a multi-user safe mode for shared analyst environments. The exam rule of thumb, job clusters for ETL, SQL warehouses for BI, and all-purpose clusters for exploration and development. A few configuration concepts the exam might like to test. Autoscaling. Databricks can automatically add and remove workers based on the workload. When there are more pending tasks than current capacity, it scales up. When the task completes and executors are idle, it actually scales down. This is different from CPU-based scaling. It's task-based. Autoscaling works on both all-purpose and job clusters. Spot instances. Cloud providers offer preemptible spot VMs at significant discount. The catch here is that the cloud provider can reclaim them with very short notice. Use spot instances for fault-tolerant jobs and don't use them for latency-sensitive or short critical jobs where a restart would be very costly. Now, talking about drivers versus workers, the driver node is the coordinator. It holds the Spark context, plans the execution, and manages the job. Workers execute the actual computation in parallel. If the driver fails, the job fails. If a worker fails, Spark retries the task on another worker. This asymmetry actually matters. The out of memory on the driver is often caused by collect pulling too much of data to the driver. Out of memory on workers is usually called by skew or very large shuffles. Databricks units are the billing units. Different cluster types have different DBU rates. SQL warehouses are built differently from standard compute clusters. You don't need to memorize DBU costs for the exam, but you should understand that different compute types have different cost profiles. Init scripts are shell scripts that run on every node when a cluster starts. They are actually used to install system level libraries or set up the environment variables. Init script failures cause cluster startup failures, which we will cover and how to diagnose them in video number 6. Now let me recap this section 1. Databricks is a Lakehouse platform which allows lake flexibility and warehouse reliability. Delta Lake provides ACID transactions, time travel, and schema enforcement and schema evolution. Unity Catalog uses 3-level namespace, catalog.schema.table, and provides centralized governance and lineage. Choose job clusters for ETL, SQL warehouses for BI, and all-purpose for interactive development. Autoscaling is task-based and not CPU-based. Spot instances save memory, but they can be reclaimed by the cloud provider. So always use checkpointing. Now in video 2, we will go deep on data ingestion and loading, the second highest weighted section. See you there. Thank you. Have a nice day.